Very good morning to all of you. Students, today we will study the derivatives of nth order of some standard functions. So these are the formulas for finding the nth order derivative of some standard functions, or we can say the nth differential coefficient of some standard function. So if we have a function like this, that is y is equal to ax plus b whole raised power m, then its nth derivative is given by yn, which is equal to m into m minus 1, m minus 2, so on up to m minus n plus 1 into ax plus b whole raised power m minus n into an. Suppose if we have a function given like this, that is y is equal to 1 divided by ax plus b. In that case, its nth derivative is given by minus 1 raising power n into n factorial into a raised power n whole divided by ax plus b whole raised power n plus 1. Note that here x should not be equal to minus b by a, because if x is equal to minus b by a, then this term goes to 0 and this whole term goes to infinity. Similarly, if we have y is equal to log of ax plus b, so means if we have a function like this, then its nth derivative is given by yn, which is equal to minus 1 raising power n minus 1, then n minus 1 factorial a raised power n divided by ax plus b whole raised power n. So here x should be greater than minus b by a. So this is basically the notation for factorial. So this is basically the notation for factorial. So this is also written as n factorial. Okay. So next formula is if we have a function y equal to a raised power mx, where a is positive, then its nth order derivative is given by a raised power mx into log of a whole raised power n into m raised power n. Similarly, if we have y is equal to sine of ax plus b, then yn is equal to a raised power n sine ax plus b plus n pi by 2, where x belongs to real numbers. If we have y is equal to cos ax plus b, then the formula is same. Instead of sin x, we have to use here cos x. Another term is that if we have a function like y is equal to e raised power x sine of bx plus c, so in that case its nth order derivative is given by yn, and it is equal to a square then plus b square then n by whole raising power n by 2 into e raised power ax sine of bx plus c plus n into tan inverse of b by a. Similarly, if we have instead of sin x we have cos of bx plus c, then we have to only change change sign with cos, and rest formula is same. Now we will solve some examples on these functions. So first example is find the nth derivative of square root of ax plus b. So here what is given, the function is given, and here y is equal to ax plus b. Okay, so I can also write it as ax plus b whole raised power 1 by 2. So we have already studied that if we have a function like this, that is y is equal to ax plus b whole raised power m, in that case its nth derivative is given by m into m minus 1 then m minus 2 so on up to m minus n plus 1 into ax plus b whole raised power m minus n into a raised power n. So I am going to use this formula for in this equation. So first of all I will take the first derivative. So differentiating equation first with respect to x. So I will write it as y1, and y1 is equal to, now the differentiation of this is 1 by 2 into ax plus b whole raised power 1 by 2 minus 1 into differentiation of ax, which is a. So this is equal to 1 by 2 then ax plus b whole raised power minus 1 by 2 into a. So this is our first derivative. Similarly, I will again differentiate this equation with respect to x. So I will get y2. So y2 is equal to, now it will become 1 by 2. Then power goes down, that it is minus 1 by 2, and it will become ax plus b whole raising power minus 3 by 2 into a square. Similarly, again differentiating this equation with respect to x, I will get the third derivative, that is y3, and this is equal to 1 by 2, then it is minus 1 by 2, then it is minus 3 by 2, then ax plus b whole raising power minus 5 by 2 into a cube. So further, I can also rewrite this equation as minus 1 whole square, then it is 1 into 3 whole divided by 2 cube, then it is ax plus b whole raised power uh, 1 by 2 minus 3 into a cube. Okay, so because I am doing this, because here m is basically our 1 by 2, so we get again this quantity, that is minus 5 by 2. When I will solve this, that is minus 1 by it is 1 by 2 minus 3, so it goes to just a second, it goes to taking LCM, I will get 1 minus 6, and this is equal to minus 5 by 2. So again I will get the same power, that is minus 5 by 2. So this is only the way I am writing this in this form, basically this one. Okay, so here m is equal to 1 by 2. So this is our third differential coefficient, or we can say this is our third derivative. Similarly, we can write that its nth derivative is equal to yn, which is equal to, again this will become minus 1, it is square. So if it is third derivative, then here the power is square. So here it is nth derivative, the power will become n minus 1. Then 1 into 3 into 5 and so on up to 2n minus 1. Okay, then it will become ax plus b, now 1 by 2, and instead of 3 here, because it was third derivative and I have written here 3, but here it is nth derivative, so I will write here n into a raised power n. So this whole divided by 2 raised power n. Okay, so this is the nth derivative. So finally, I will rewrite this equation as yn, this is equal to minus 1 raising power n minus 1 into 1 into 3 into 5 and so on up to 2n minus 1 whole divided by 2 raised power n into this term I will write here. So into a raised power n, here I will write ax plus b whole raised power 2n minus 1 divided by 2. So where x is not equal to minus b by a, hence solved. I have here only taken the LCM of this quantity, and this goes to 2 minus times 2n plus 1 divided by 2. So this goes to the denominator, and I have directly written this term, that is ax plus b whole raising power 2n minus 1 by 2. So this is in power. I will rewrite it as, just a second, it is ax plus b whole raising power 2n minus 1 divided by 2. Okay, so this is the answer. So by this way we have to find the nth derivative of this function. Similarly, next example is find the nth derivative of the function e raised power x cos cube x. So first of all, I will know that what is the function given, that is y is equal to e raised power x cos cube x. So we know the cos cube x is equal to, this is equal to, this is the formula, this is equal to 1 by 4 cos of 3x plus 3 by 4 cos of x. So I will substitute this formula in this equation. So name it as equation number 1. So I will get y is equal to e raised power x into 1 by 4 times cos 3x plus 3 by 4 times cos x. Okay. So now this will become 1 by 4 e raised power x into cos 3x, then plus 3 by 4 e raised power x into cos x. So we know that if we have a function like this, that is y is equal to e raised power ax, then cos of bx plus c, then its nth derivative is given by yn, and this is equal to a square plus b square whole raising power n by 2 into e raised power ax, then cos of bx plus c plus n times tan inverse of b by a. So now I will use this formula here. So directly I will write, therefore y nth derivative of equation 2, I will write here, this is the of equation 2, this is equal to, here see 1 by 4. Now this is same like this quantity, that is e raised power ax into cos bx plus c. Here c is 0, so I will write here, this is equal to 1 by 4, then e raised power, here a is 1, so I will take 1 square, then what is b? B is equal to 3. So b is 3, so it will become 3 square raising power n by 2. Then e raised power ax, and a is 1, so here it will become e raised power x. I will write here a is equal to 1 and b is equal to 3. So now it is cos of bx. Now b is 3, so it will become 3x, and here c is 0 because we have ex into cos of 3x, plus c term is missing. So c is 0 here, so it will be 3x plus 0 plus n into tan inverse of b by a. B is 3 divided by a, this is 1. Okay, this is the first term. Then again second term will be plus 3 by 4, then again it will be e raised power x cos x, and we will use this formula. Okay, it will be a square, that is 1 square plus now here b is 1, so in this case b is 1. In this case it was a equal to 1 and b equal to 3, but in this case a is equal to 1 and b is also equal to 1. So it will become 1 square, then plus b square, that is 1 square again, then e raised power ax, here it is n by 2, e raised power ax, so a is 1, so it becomes e raised power x, then it is cos of bx, again b is 1, it will be x, then c is 0 plus n into tan inverse of 1, that is b by a, 1 divided by 1. So this is the second term. So finally I will write it as 1 by 4, so this goes to 10 raising power n by 2 e raised power x cos of 3x plus n into tan inverse of 3 plus 3 by 4 into, it goes to 2 raised power n by 2, then e raised power x cos of x plus tan inverse of 1. It is basically pi by 4. So it goes to cos of x, then plus n pi by 4. So this is the answer. So this is the way to find the nth derivative of this function. Next example is that find the nth derivative of log of x square minus a square. So here I will write y is equal to log of x square minus a square. Further, I can write it as log of x minus a and x plus a. So this is the property of log. So it will become log of m plus n. Log of x plus a, then log of x minus a. So now this is same as the property number 3, which is if y is equal to log of ax plus b, in that case its nth derivative is given by yn, which is equal to minus 1 raising power n minus 1 into n minus 1 whole factorial a raised power n whole divided by ax plus b whole raised power n. So where x should be greater than minus b by a. So here I am again using this property. So I will write therefore y nth derivative, this is equal to, so now see here first term is log of x plus a and second term is log of x minus a. So this will become minus 1 raising power n minus 1 into n minus 1 whole factorial. Now what is a? So I will write here a is 1. So in this case I will write it as a first part and this is second part. In first part a is basically equal to 1. Similarly in second part a is also equal to 1. So in formula it goes to 1 raised power n. So whole divided by ax plus b. So here again a is 1. So it will be x and instead of b I have here a. So I will write in first part b is equal to a and in second part b is equal to minus a. So put here, so it is x plus a whole raised power n. Then plus, then second part again minus 1 raising power n minus 1, n minus 1 whole factorial. Then again here a is 1, so it goes to 1 raised power n whole divided by ax. A is again 1, it goes to x, and b is here a minus a, so it will be minus a whole raised power n. So I will write it as minus 1 raising power n minus 1 into n minus 1 whole factorial. Then it will be 1 divided by x plus a whole raised power n, and it will be plus 1 divided by x minus a whole raised power n. So this is the answer. So this is the procedure to how to find the nth derivative of this function, which is log of x square minus a square. So thank you.